Hello and welcome to a new video on IGCSE Physics Mechanics. Today we will be discussing acceleration and free fall. We will begin with general questions about acceleration and motion. Below are 4 statements about acceleration. Which statement is not correct? So in order to solve this question, we need to remind ourselves what acceleration means. Acceleration is a change in velocity. And velocity is not exactly the same as speed because it contains 2 factors. Speed, which is the magnitude of the velocity. I'm moving at 100 kilometers per hour, for example, and direction. So if I say I'm moving at 100 kilometers per hour, this is my speed. If I say I'm heading to the north at a speed of 100 kilometers per hour, then these 2 pieces of information together constitute what we call the velocity. So velocity contains speed and direction. So acceleration is the change in velocity. Let's now look at the 4 statements and see which of them is not correct. So acceleration always involves changing speed. This is exactly the opposite of what we just said, because acceleration is the change in velocity, not speed. So can I accelerate without changing my speed? Yes, I can. Take this example. So if we're running around a track at a constant speed, I'm running laps around the track at a speed of, let's say, 5 kilometers per hour. Okay. So is my speed constant? Yes, my speed is constant. But is my velocity constant? No, my velocity is not constant because my direction is always changing. Since I'm running around in a circle, my direction at any moment is different from my direction in the previous moment. So even though my speed is constant, since my direction is changing, I can say that my velocity is changing. And if my velocity is changing, then I am accelerating. So this example shows us that we can move at a constant speed and accelerate at the same time. Therefore, the correct choice in this question is choice A. Acceleration always involves changing speed. This is not correct. Just for learning purposes, let's go through B, C, and D and discuss why they are correct. So for B, it says changing direction always involves acceleration. Let's go back to our diagram. If my direction changes, then my velocity changes, which means that I'm accelerating. So B is a correct statement. So it doesn't work for this question. C says changing speed always involves acceleration. Is this correct or not? Of course, this is correct. Because if the speed changes, then the velocity changes, then I'm accelerating. What about choice D? Circular motion always involves acceleration. This is similar to the example we said at the beginning. If I'm moving in a circle, then I'm constantly changing my direction. So therefore, I must be accelerating. And for your general knowledge, moving in a circle gives me a special type of acceleration that we call centripetal acceleration. And it's directed towards the center of the circle. So moving in a circle gives us what we call centripetal acceleration. Right? So For this question, the only incorrect statement is statement A. Acceleration always involves changing speed. This is incorrect because acceleration could involve changing direction without changing the speed. Let's try some applications. A sprinter runs a 100-meter race in a straight line. The table shows how his speed changes with time for the first 5 seconds of the race. What is the average acceleration of the sprinter between time 2 and time 3 seconds? As we said, acceleration is the change in velocity. You should know this equation: final velocity V equals U plus AT, where U is the initial velocity and V is the final velocity. Some people prefer it in this format: A equals V minus U over T. Again, U is the initial velocity, V is the final velocity. So in order to get the acceleration here between time 2 and time 3, I take 2 as my initial time. So my initial velocity is 4.1 and my final velocity is 5.7. And the elapsed time here is 1 because between 2 and 3, only 1 second has elapsed. So by plugging into either of these equations, I can simply calculate my acceleration as 5.7 minus 4.1 over 1. And this gives us 1.6. So the correct choice here is choice A. The table shows the readings on a car speedometer at 5-second intervals. Which row describes the speed and the acceleration of the car? So is the speed increasing or decreasing? I think you can just observe the table and figure this out. Obviously here, the speed is increasing because it was 0 and then became 30, 50, 60. So obviously the speed is increasing. Now, if the speed is increasing, is my acceleration 0 or not 0? Of course, if my speed is increasing, then my acceleration is not 0 because acceleration involves changing velocity. And if my speed is increasing, then my velocity is increasing. So therefore, the acceleration is not 0. Next, we move on to what we call free fall. If I take any object and drop it, so if I'm standing right there, this is the ground, and I have a ball and I drop it, what happens to the ball? Obviously, it falls to the ground. Why does it fall to the ground? Because it is pulled by the gravitational force due to the Earth. So the Earth pulls objects towards it due to the gravitational field that creates a gravitational force on any object. So what do we need to know about this phenomenon? Well, we need to know that the acceleration in free fall is constant, and it is equal to 9.81 meters per second squared. But it is only constant if we do not take into account air resistance. So this equation or this value assumes that there is no air resistance. Now, if we do have air resistance, the acceleration will not be constant. It will be changing, and we're going to discuss this in this video. But for the general case, assuming we're in a vacuum or just neglecting air resistance, we're not taking it into account, then the acceleration is constant at 9.81 meters per second squared. Moving on to the questions. A large stone is dropped from a bridge into a river. Air resistance can be ignored. There it is. So I can ignore air resistance. Therefore, my acceleration here is going to be constant. So we're between choice A or choice B. Now, if the acceleration is constant, constant does not mean 0. We just said acceleration is 9.81 or approximately 10. So the acceleration here is constant, but not zero. So is the speed constant or increasing? We said that acceleration means changing speed. So the speed cannot be constant. The speed must be increasing. Hence, the correct choice here is choice B. A boy throws a stone. The stone leaves the boy's hand and moves vertically upwards. Air resistance can be ignored. Air resistance can be ignored means that the acceleration is constant. How should the force on the stone be described just after the stone leaves the boy's hand? So the boy throws the stone and it moves up, and then inevitably it's going to move down to the ground. We don't care about the direction of motion now. We just care about the stone, while it's in the air. And we want to know what the force acting on the stone is. So since it's going to be pulled downwards inevitably, so the force obviously must act downwards. And since it produces a constant acceleration, so it makes sense to assume that the force itself is constant as well. So therefore, the correct choice here is choice A. The force is downwards and constant. A heavy object is released near the surface of the earth and falls freely. Air resistance can be ignored. Notice that they always say air resistance can be ignored when they want you to assume constant acceleration. Which statement about the acceleration of the object due to gravity is correct? We just said that the acceleration must be constant. We don't care about the mass, we don't care about the volume, and the acceleration does not increase. It is constant, only because they said air resistance can be ignored. So the correct choice here is C. Now, on Earth, a ball is dropped and falls 2 meters in a vacuum. So saying that it falls in a vacuum is another way of saying that air resistance can be ignored. The acceleration of the ball at 1 meter is 10 meters per second squared. You can say 9.81, you can say 9.8, you can say 10, depends on how much you're approximating it. So what is the acceleration of the ball at 0.5 meters? So this is a trick question. How is it a trick question? They give you all these numbers, 2 meters in a vacuum, 1 meter and 5 meters and 1.5 meters and whatnot. This is all irrelevant simply because the acceleration of the ball is constant. And since it is 10 meters per second squared, as we know, then it will always be 10 meters per second squared, regardless of where the ball is. So the acceleration due to gravity is, like we said, 9.81 or 9.8 or 10. And this is a constant value as long as we are ignoring air resistance. So the correct choice here is choice B. A ball is dropped in an evacuated tube. Again, evacuated means this is similar to the word vacuum, and this is similar to saying that we are ignoring air resistance. There is no air resistance here. A series of photographs is taken at equal time intervals from the time of release. Another ball of the same size, but twice the mass, is also dropped in the same evacuated tube and photographed. Which diagram shows the motion of the heavier ball? Vacuum means no air resistance, which means constant acceleration. So any ball dropped from the same height will start with zero velocity and will keep accelerating at the same rate, which we said is 10 or 9.81. So basically, without confusing yourself, the correct choice here would have to be B, because we don't really care about whether the ball is heavier or lighter. Any ball will drop in exactly the same pattern as the first ball, since the acceleration is constant regardless of the mass. So the correct choice here is choice B as well. A stone falls freely from the top of a cliff. Air resistance may be ignored. Air resistance may be ignored means that the acceleration is constant. Which graph shows how the acceleration of the stone varies with time as it falls? In the exam, you're usually tense, so you're just going to have to start looking at the graphs, analyzing the graphs, trying to figure things out. The graphs here are irrelevant as well because we said that the acceleration is constant. The acceleration does not change. So therefore, the correct choice here is choice D. This is also a tricky question because it gives you all these complicated graphs and you are inclined to investigate them, even though all you had to do is just focus and take care that air resistance may be ignored, and therefore the acceleration here is constant, does not change. So the correct choice here is D. Now, these were all basic questions about, or with the purpose of testing one concept, that if you ignore air resistance, acceleration is constant. These following questions are a bit more challenging, but they're pretty much testing the same concept. We have 4 balls with different masses dropped from different heights. So now they're dropped from different heights. Again, air resistance may be ignored, which means that their accelerations are constant. Which ball has the greatest average speed? So they gave you all these numbers again to confuse you. The masses do not matter. This is something you need to take particular care of. The masses do not matter when something is falling under the effect of gravity. But the distances would matter here because the first ball here at D, the highest ball, takes the longest time to fall since they all start with the same speed and they all have the same acceleration. The one that has to move the greatest distance will obviously take the greatest time. And since it's taking more time, its speed keeps increasing and increasing and increasing because it's accelerating for a longer time. So therefore, this ball has the greatest average speed. And you can just think about this using your common sense. If a ball is dropped from a greater height, obviously, if you think about it, it will keep picking up speed, picking up speed, picking up speed, and it will hit the ground with the greatest speed. So the correct choice here is choice D. This is a similar question. Again, the same 4 balls with different masses dropped from different heights. Now we're asked which ball has the smallest average speed. Obviously, by common sense, if D has the greatest average speed, then A has the smallest average speed. Same question again, but now we are asked which ball hits the floor first. You might be tempted to think the one with the greatest mass might fall faster. This is completely not true. We said mass is irrelevant. They all start with 0 speed because I'm dropping them. I'm not throwing them. I'm just dropping them. So as soon as they leave my hand, their speed is 0, but they start accelerating because they're pulled by the earth and their speed keeps increasing. So they all start with 0 speed and they all accelerate. But obviously, since they have the same initial speed and the same acceleration, the one that reaches the ground first is ball A. So the correct choice is A. The same 4 balls again. These are all different exam questions in different years. We want to know which ball hits the floor last, and obviously this is going to be choice D. Now moving on to a different concept. Terminal velocity is a concept that, unlike previous questions, does take air resistance into account. So far, we've been ignoring or avoiding or neglecting air resistance, but starting now, we're going to be taking air resistance into account. Excuse me. So what happens when an object falls under the effect of gravity? Assuming that we do take air resistance into account. So let's say our object has a weight of 10 newtons. As soon as it is dropped, the only force acting upon it is the 10 Newton force, and it is directed downwards. And this force produces an acceleration like we said before, of 9.81 meters per second squared. So since the object is accelerating, its speed increases. And what we need to know is that air resistance increases when speed increases. So since the speed is initially 0, the air resistance is initially 0, but then the speed increases, so the air resistance becomes maybe 1 newtons. So now, if the weight is 10 and the air resistance is 1, the object has a resultant force of 9 newtons. So the resultant force on the object decreases. Now, what happens? Well, we still have a 9 Newton force pulling us downwards, so we're still accelerating downwards, which means that the speed keeps increasing. And then when the speed keeps increasing, the air resistance keeps increasing as well. So instead of 1 newtons here, I'm going to have maybe 5 newtons. And then what happens when I have 5 newtons pushing me up? The resultant force here becomes 10 minus 5, which is 5 newtons as well. Again, the resultant force is still 5, pulling me downwards. And this tells me that I'm still accelerating and my speed is increasing. So air resistance keeps increasing up until maybe 8. Now, if I have an air resistance of 8, my resultant force or my net force here is going to be, my resultant force is going to be 2 newtons, 10 minus 8. Again, I still have a resultant force downwards, so I'm accelerating downwards. The speed is increasing and the air resistance is increasing as well. So this process keeps occurring until air resistance reaches 10 newtons. And what happens when the air resistance reaches 10 newtons? Basically, you get what we call terminal velocity. Why do we call this terminal velocity? Because if the upward force equals the downward force, you have a 0 net force or a 0 resultant force. There is no resultant force. If there is no resultant force, there is no acceleration. The speed doesn't change. It's a constant velocity and nothing else happens. This is the final stage that we reach. Unless, of course, we're talking about a parachutist and he opens his parachute and then maybe the story continues. But for the sake of any regular object, like we said, it starts with acceleration, and the acceleration keeps decreasing until it reaches a 0 value, at which point the speed becomes constant, and we call this terminal velocity. So this is a speed time graph, and this threshold here is our terminal velocity. The following questions will be targeting this concept. Let's move on. So this is what we were just discussing. The diagram shows vertical forces acting on a ball as it falls vertically through the air. The ball does not reach terminal velocity. So it is the phase before terminal velocity where we have weight and we have air resistance. We want to know what happens to the resultant force on the ball and what happens to the acceleration as it falls through the air. Like we said, since the air resistance keeps increasing, the resultant force decreases, and therefore the acceleration decreases, but doesn't really reach 0 yet, but it is approaching 0. It's decreasing and decreasing until it reaches 0, which is what we call terminal velocity. So the correct choice here is choice A. A feather falls through the air, its downward speed is constant. Which statement about the feather is correct? So if the speed is constant, which phase is that? Obviously, terminal velocity. So if we have a constant speed, what is my resultant force here? So since the speed is constant, I have to have zero acceleration, which means zero resultant force. In this case, my weight is equal to the air resistance. I have zero net force. So the feather experiences no resultant vertical force. So the correct choice here is choice C. A skydiver reaches terminal velocity, then he opens his parachute. What happens to the skydiver as the parachute opens? So this is the continuation of the story that we said. The parachutist starts with an acceleration that keeps decreasing until he reaches terminal velocity, like we said before, and he has not opened his parachute yet. At this point of terminal velocity, what are the forces acting? So you have some sort of weight, let's say 100 newtons. Actually, this is not very accurate, but anyway, probably something more like 600 newtons. And then the air resistance acting on him has to equal also 600 newtons as well. Now he opens his parachute. So what happens when he opens his parachute? Bear in mind that so far he is falling vertically downwards and he reached a constant speed. What happens when he opens the parachute? Suddenly, of course, the weight stays the same, but suddenly the air resistance increases dramatically. So instead of 600, I now have 1,500 newtons of air resistance, for example, because he opened his parachute and the parachute has a large surface area of some sort, so it increases air resistance dramatically. So what happens then? Does the weight decrease? Obviously not. Does he move upwards? He doesn't fly, obviously. He keeps falling, so movement upwards is illogical. Does his speed increase? That wouldn't make any sense, because if the parachute increases his speed, he would hit the ground harder and he would die. So that also doesn't make sense. There is acceleration upwards. Does that make sense? Yes, that makes sense. Why does that make sense? Because the net force here is 900 newtons upwards. So the upward force is greater than the downward force. So the resultant force is upwards. This might be confusing because you might be thinking to yourself, how can he accelerate upward? How can this be correct and this be false at the same time? Can that happen? Can I be moving downwards? Can this be my direction of motion and simultaneously be accelerating upwards? Yes. Acceleration has nothing to do with the direction of motion. I can be moving to the right. I can be driving my car in the right direction, and then I suddenly press my brakes. What happens when I press my brakes? So this is my velocity. My velocity is to the right. And then I press my brakes suddenly, so I'm accelerating to the left. That works. When the acceleration and the velocity have opposite directions, that means that my speed is decreasing. So acceleration and velocity do not necessarily mean the same, do not necessarily have to be in the same direction. I can be moving in a direction and accelerating in the opposite direction. And this is what happens in the case of the parachutist. He's still moving downwards, so this is his velocity, but now he's accelerating upwards because the parachute itself increased his air resistance. So what happens in his case? He's moving downwards, but accelerating upwards, which means that his speed is decreasing, which is the whole point of a parachute. You want to decrease your speed so that you reach the ground at a slower speed and land softly, in a sense. So this is what a parachute does. Therefore, the correct answer here is there is acceleration upwards. Choice B is the correct answer. A ball of weight 1.2 newtons drops through the air at terminal velocity. A sudden gust of wind exerts a horizontal force of 0.5 newtons on the ball from the left. Which diagram shows the resultant force on the ball while the wind is blowing? This is also a tricky question because the choices look complicated. But all you had to do here was just focus on this term, terminal velocity. So before the 0.5 newtons came along, we were moving at terminal velocity, which means no net force. So other than the 0.5 newtons, I have to have zero net force. And the only choice that satisfies this condition is choice C, because the upwards force equals the downwards force. So they cancel out in a sense. So before introducing the gust of wind, the 0.5 newtons, I have to have had zero net force. And therefore, choice C is the correct choice, because all of the others have the 0.5 and another force, another acting force. So if we remove 0.5 here, could I have been moving at terminal velocity? No, because I have a net force. Same for B, same for D. So the only correct choice here is choice C, because it is the only one that gives you zero net force other than the 0.5 newtons that was introduced by the gust of wind. When does an object falling vertically through the air reach terminal velocity? When air resistance equals the weight of the object. Because terminal velocity means zero acceleration and zero net force, which is what we said when we first explained terminal velocity. An ice crystal falls vertically from a cloud. What happens to the acceleration of the ice crystal as it falls? So you might be tempted here to think about constant acceleration, but you shouldn't, because they did not say air resistance could be ignored. So there is air resistance here. If I have air resistance, what happens to my acceleration? Like we said before, it decreases because of the air resistance. The net force decreases, so the acceleration decreases. Hence, choice A is the correct choice. This concludes our video. I hope you found it valuable. Thank you for listening in.